Chapter 7 review sheet. Let's go ahead and jump right into this. The directions for numbers 1 through 15 odd. Say to simplify the expression. Now, when I say simplify on a test, that means simplify as far as you can. And it does mean to have no negative exponents. Let me say that again. I want no negative exponents for your answers. Okay, so here we go. 5 to the second times 5 to the sixth. Well, you could type this whole thing into your calculator, but I'm going to use my exponential properties real quick here. I'm multiplying like bases. My base is a 5. And my base is a 5. So when you're multiplying like bases, write the like base once and add the exponents. And now with your calculator, type in 5 to the 8th power, and your answer will be 390,625. Now, on your test, I might leave your answer like this. I'm not sure yet, but in fact, I probably will. So, either way, they'll know how to do both of these. Okay, number 3. We're multiplying like bases. I have a base of x and a base of x. When you're multiplying like bases, write your base once and add the exponents. Now, that's unacceptable because we have a negative 1. So remember, you can put anything over 1. So put it over 1. Now, the 1 down here has a power of 1. It's positive. I have no problem with that. But this exponent's negative. So I have to pick this whole thing up and bring it down to the denominator to make this negative 1 become positive. So there's already a 1 down here. Times, I bring my x down, and the negative 1 becomes positive 1. There's nothing left up top, so I put a 1. Well, guys, having a 1 up top is no big deal. That's fine. X to the 1 power is just x, and 1 times x is x. So there's your answer, 1 over x. Okay? Please remember how to do these. Number 5. Here is an example of a power being raised to a power. Now notice we're not multiplying like bases. In fact, we only have one base. It's a y. We have a power being raised to a power. When that happens, you multiply your exponents. So your answer would be y to the negative 12. Now, that's unacceptable because we have a negative exponent. So I'm going to put all of this over 1, and here we go again. We want the 12 to be positive, so pick this up, move it to the bottom. When you do that, you already have a 1 down there. Times, now you have a y to the positive 12th. There's nothing left up top, so we'll put a 1. So your final answer is 1 over 1 times y to the 12th is just y to the 12th. And that is your answer, 1 over y to the 12th. Alright, moving on to number 7. Okay, now, be careful here. We have 6 and x being raised to the second power. This is one term right here. Now, if I would have had a plus sign here, or a minus sign here, then I would have had 2 terms. If you would have had more than one term, then you cannot do what I'm about ready to show you to do. But as long as you have one term, and we do, they're multiplying here, so that's one term. As long as you have one term, you are allowed to multiply the exponent through. So the exponent of the 6 is 1, even though you can't see it. The exponent of x is 1. Take your 2 and multiply it through. 2 times 1 is 2. 2 times 1 is 2. And then obviously 6 squared is 36. So your answer is 36x squared. Moving on to number 9. Okay, now, hopefully you remember what I taught you. Anything to the 0 power becomes 1. So I have 3 times x to the 0 power times y. So what I really have is 3 times 1 times y, because anything to the 0 power, that whole thing becomes 1. Now, a lot of students see this 0 and cross the whole thing off and say the answer is 1, and that's incorrect. Now, if the problem would have looked like this, 3xy in parentheses with a 0 out here, then yes, the whole answer just becomes 1 because you've got this whole expression to the 0 power. In other words, you would multiply the 0 the 0, x to the 0, y to the 0. That's 1 times 1, which is 1. But we don't have that here. The only thing to the 0 power is x. So this becomes 1. So 3 times 1 is 3 times y is 3y. So your answer is 3y. Number 11. Alright, you were taught that when you're dividing like bases, write the base once up top and subtract the top minus the bottom. So 5 minus 7 is negative 2. Now there's nothing left in the denominator, so we put a 1. Let's go over that again. When you're dividing like bases, you write the like base. What is your base? X. What is your base? X. They're like bases. You write your like base once up top in the numerator, and then subtract. You take the top minus the bottom and put that up top. Now, we do not want negative exponents in our answer, so we're going to take this and bring it down to the bottom. So I have 1 already down here times x squared. Nothing up top, so I'll put a 1. So the final answer is 1 over x squared. 1 over x squared. Alright, moving on to number 13. Okay, a little more complex. Now we're going to mix in multiplying and dividing, okay, which will be good for us. Now, we have a fraction times a fraction. So top times the top, right? I have a 1 right here. So 1 times 18 is 18. Y to the 6th, there's no y over here. X, there's no x over here, so there we go. Now on to the bottom, the denominator. There's a 1 here, so 6 times 1 is 6. X to the 4th times x squared, like bases. Write the base ones, add your exponents. There's a y here, no y over here to multiply, so we'll put a y. There we go. Now let's simplify, okay? Let's simplify this. First of all, let's start with our coefficients. 6 goes into both of these numbers. So now I have a 3 and a 1. Now I have y to the 6th over y to the 1 right here. I'm dividing like bases. I can do all this as long as I have one term up top in the numerator and one term down bottom, down below in the denominator. Now, when you're dividing like bases, y and y, you write the like base once up top, and you take 6 minus 1, which would be 5. Now let's move on to our x's. We have x to the 1. We're dividing like bases. Write the like base once. 1 minus 6 is negative 5. Now, we're almost done, but we don't want a negative exponent. Don't move this. This has a positive 5. Don't move this. This has a positive 1. Don't move this. This has a positive 1. Okay? Let's move this down to the bottom to make the negative become positive. So now up top I have 3y to the 5th. In the denominator there's a 1 there already. I have 1x to the 5th. You do not need the 1 if you don't want to. And that should match our answer right there, hopefully. Alright. So there we go. We know we're finished. Because I have a 3 and a 1. You can't reduce a 3 over 1. There's a y here but no y down here. There's an x here but no x up here. So we know we're good. Alright. Number 15. Okay, same type of problem. Here we go. Let's multiply top times top. The two fractions are multiplying. There's a 1 here. 4 times 1 is 4. There's a y here but no y over here. There's an x here but no x over here. And now let's go to the denominator. There's a 1 here. 1 times 2 is 2. There's an x here but no x over here. There's a y here but no y over here. And now let's simplify. Here we go. I have a 4 and a 2. 2 goes into both of those. So 4 over 2 is 2 over 1. Now, let's look at your x's right here. We're dividing like bases, an x and an x. When you're dividing like bases, write the base once up top. And take the top 3 minus the bottom 2. 3 minus 2 is 1. If you don't want to put that 1 there, you don't have to. Now look at your y's. We're dividing like bases y and y. When you're dividing like bases, write the base once up top. And then subtract 2 minus 4. Negative 2. This is really like the last problem, guys. Don't move the 2, it has a positive 1. Don't move the x, it has a positive 1. Don't move the 1, it has a positive 1. All of their exponents are positive, even though you couldn't see them. But this y has a negative 2, so pick this up, bring it to the denominator. So up top I'm left with 2x. In the bottom I'm left with 1y. Square root of the negative 2 became positive. And if you don't want the 1, you do not have to put it. And there's your answer. Okay, moving on now to 25 through 44. The directions say for 25 through 32, evaluate without using a calculator. So we've got to think of four numbers multiplied together that would give me 625 because we're looking at a fourth root, which means I want four numbers multiplied together. That would give me 625, but they have to be the same number. We know it's not 3. That's what? 81. Maybe 4. 64, 64, 24, 2. No, that's not it. I think 5's going to be it because 5 times 5 times 5 is 125 times 5 is 625. So there, I did it without using a calculator. The fourth root of 625 is 5 because 5 times 5 times 5 times 5 is 625. Alright, 243 to the 1/5. Now don't forget what that means. That means the fifth root of 243 to the 1 power. Okay? The bottom of the fraction goes here, the top of the fraction goes here, so we can do this pretty quick. We know I don't think it's going to be, it might be a 3. Let's see, 3 times 3 is 9, 27, 8, 81 times 3. Yeah, it's 3. 3 times 3 is 9, times 3 is 27, times 3 is 81, and 81 times 3 is 243. Just like that. 5 3's multiplied together give me 243. So the fifth root of 243 would be 5, or 3, excuse me. And guys, I did that without a calculator, okay? It's pretty simple. Alright, number 27. Okay, here we go. Get a little more difficult, but not that bad. 1/6 means the sixth root of 729 to the first power. So I need 6 numbers multiplied together. It might be 2, but I seriously doubt it. 2 to the 6th power would not be that big. We can try 3 to the 6th power. That might be it. Let's see if it is. Now, students, we'll try 3. 3 might be it. Let's see. 3 times 3 is 9. 3 times 3 is 9. 3 times 3 is 9. 9 times 9 is 81. 81 times 9. Yep, there it is. 729. So when you take 3 times 3 times 3 times 3 times 3 times 3, you get 729. So the sixth root, excuse me, of 729 is 3. Number 28. Alright, the cube root of 64. Now let's think of 3 numbers that multiplied together give me 64. I'm pretty sure it's going to be 4. 4 times 4 is 16, and 16 times 4 is 64. So, I mean, guys, there's really no way to do this. I have a lot of practice experience with this, but just start with 2. 2 times 2 times 2, that's not big enough. 3 times 3 times 3, not big enough. 4 times 4 times 4, and there it is. So the cube root of 64 is 4. Alright. Number 29. Okay, now be careful here. We have our first negative exponent in this section of using numbers here. So, we can put this whole thing over 1, okay? And then bring this down to the bottom to get rid of the negative exponent. So now I have 1 times 512 to the positive 1/3. Does everybody see that? Nothing up top, so put a 1. 1 times anything is just itself. So 1 times 512 to the third power is just 512 to the third power. Now, 512 to the third power is 1 over the cubed root of 512. So what 3 numbers would multiply together give you 512? That's going to be a pretty big number because we only want 3 numbers. And they have to get all the way up to 512. Let's see, 6 times 6 is 36. That's not even close. 8 times 8 is 64. 9 times 9 is 81. That's 2. Let's try 8. 8 times 8 is 64. That'd be 32. That's it. 8 times 8 is 64. And by the way, I did not look at the answer. I'm just doing this randomly in my head. 8 times 8 is 64. And 64 times 8, 32. Carry your 3. 512. So you can't just drop this 1. You still have a 1 up top. And the cube root of 512 is 8. Because 8 times 8 times 8 is 512. How did I know I wanted 3 8s and not 4 or 5 8s? Because of this 3 right here, it's a cubed root. So I wanted 3 numbers that are the same being multiplied together. That would give me 512. So my answer is 1/8. Alright, moving on. Okay, students, this will be good practice for you because it's very similar to the last problem. Maybe you want to pause the video and try this on your own. That's up to you. Okay, notice I have a negative exponent, so I can put this whole thing over 1. Now I'm going to pick this up and move it to the denominator. So now I have 1 over 1 times 27 to the positive 1/3. And of course, 1 times anything is just itself. Now, 27 to the 1/3 is the cubed root. I should get parentheses around it. Sorry about that. The cubed root of 27 to the first power. And of course, 27 to the first power is just 27. So the cubed root of 27, what 3 numbers that are the same when multiplied together give me 27? Well, that should be 3, 3, and 3. 3 times 3 is 9, times 3 is 27. So 1 over the cube root of 27 is 3. So there we go. 1/3. Number 31. Okay, the 4th root of 16. I want 4 numbers multiplied together that are the same number that have a product of 16. Alright. So, we're looking at probably 2. 2 times 2 is 4. 2 times 2 is 4. And 4 times 4 is 16. So yes, the 4th root of 16 is 2. Moving on to 32. Alright, the 5th root of negative 32. Now, as soon as you realize you have the 5th root of a negative number, as soon as you realize your radicand is negative, you might be tempted to put no solution. Well, hold on. If the index is odd, the 5th root, 3rd root, 7th root, 9th root, 11th root, if your index is odd, you are allowed to have a negative radicand. Now, if this index was even, 2nd root, 4th root, 6th root, 8th root, then you would put no solution. Well, actually, if it was a square root, you know what to do. Put a plus sign and put the letter I here. But that's only for a square root, okay? And we're not dealing with imaginary numbers right now in this chapter anyways. But it's a 5th root, so you're allowed to have a negative. That's fine. So I want 5 numbers when multiplied together that give me a negative 32. Well, guys, I think it's going to be negative 2. Negative times a negative is positive 4. Negative times a negative is a positive 4. Bring down your negative 2. 4 times 4 is 16. 16 times negative 2 is negative 32. So if I have 5 negative 2's, their product is negative 32. So the 5th root of negative 32 is negative 2. Alright, now number 33, we have fractional or rational exponents. No big deal. Let's just keep our minds here and relax and not get all bothered by this. And let's realize that we're multiplying like bases. So when you're multiplying like bases, write the like base once. And now add the exponents. If you struggle with fractions, then use your calculator. 1/4 minus 9/4 would be a negative 8/4. Of course, negative 8/4 is just negative 2. So there we go. Well, guys, we know what to do from here. Put it over 1. Pick this whole thing up and bring it down to the bottom. So now we have 1 times 5 to the positive 2. This negative 2 became a positive 2. When we moved it down to the denominator, nothing left up top, so I'll put a 1. So my final answer is simply 1 over 25 because I've got a 1 up top. 5 times 5 is 25 times 1 is 25. So 1 over 25. Alright, 34. Okay, now here I'm not multiplying a base times a base, okay? I have a power raised to a power. So you write the base like this, and then multiply your exponents. 1/3 times 3/4 is 1/4. 5 to the 1/4. Okay, now 5 to the 1/4. Don't forget is the same thing as the fourth root of 5. Sometimes it's good to do that, is to look at it, but we really can't do anything with that. So your original problem did not have radicals, it had fractional exponents, so you want your final answer to have fractional exponents. Don't write it like this. So your answer is 5 to the 1/4. 35. Alright, here we go. Now, we're multiplying radicals. Do you remember what I taught you? Let me say that again. You're multiplying radicals. Do you remember what I taught you? When you're multiplying radicals, all that you have to do is have a common index. That's it, nothing else. And we do have a common index. So we write a cubed root. Then you multiply the outside times the outside. Well, 1 times 1 is 1, and we won't have to worry about that. Then inside, or radicand times radicand. 16 times 1/4 is 4. So the third root of 4. Now, there's really a 1 here. You could write your answer like this. But since your original problem was with radicals, then we're going to write our answer with radicals. There's nothing you can do with this. The cube root of 4, there's nothing you can do. Cube root of 4. Alright, number 36. Alright, now be very careful here. We have a 1 here. The 81 has a power of 1, and x has a power of 1. This is one term being raised to the 1/4 power, so we take the 1/4 and we multiply it through. 1/4 times 1 is 1/4. 1/4 times 1 is 1/4. Okay, now your original, well, first of all, 81 to the 1/4 can be simplified. That's the fourth root of 81 to the 1 power times x to the 1/4. So I took this here and I wrote it in a radical form. Now the fourth root of 81 is going to be 3, because 3 times 3 is 9, times 3 is 27, times 3 is 81. So the fourth root of 81 is 3, and then bring down your x to the 1/4. Now why would you not write your answer like this? X to the 1/4 is the fourth root of x. Well, you could. This is perfect. The 3 would not be inside the radical because the 3 has a power of 1, not 1/4. Okay? But your original problem had fractional exponents or rational exponents, so your answer should be written with rational exponents. Moving on to number 38 or number 37. Okay, we have 200 to the 1/3 power. Okay, now the 200 has a power of 1, the 8 has a power of 1. Alright? So I'll do it a different way. Since we have this entire thing in a parentheses, that means the whole thing is the 1/3 power. So that's the same thing as saying the cubed root of 200 over 8 to the 1 power, or in other words, 200 over 8. Now the cube root of 200 over 8 is the same thing as the cube root of 200 over the cube root of 8. Do you see what I've done there? This entire fraction is to the 1/3 power, and of course 1/3 power means cubed root. Now, the cube root of a fraction, you can split that up into the cube root of two different numbers. So I have the cube root of 200 over the cube root of 8. I do not know the cube root of 200, but I do know the cube root of 8 is 2. Alright? Now, I'm trying to think of any more simplifying we can do. There is actually, because remember what I've taught you. Hey, we don't know the third root of 200. Okay? We do not know the cube root of 200. However, come on, watch this, guys. We can list out the prime factors of 200. There we go. And remember what to do. It's a 3 right here. So we're looking for sets of 3 numbers that are the same way we are. Every set you put 1 on the outside. So really what I have now is I've got a 2 and a 2 and a 2. It's 3 2s, so we put a 2 on the outside. I'm left over with 25. All over what number? 2. Okay? Now, this is all one term. They're all multiplying here. This is one term. So we can reduce it. Outside number. If this was a 26, and there was no 2 here, you could not reduce these two numbers because one is an inside number, it's under the radical, one's an outside number, okay? So, but in this case here, we do have outside number 2, so there we go. So we're left with 1 cube root of 25 all over 1. Well, you don't need the bottom 1, and you don't need this 1 either right here. So you're left with the cube root of 25. Now really, there's nothing else you can do with this, but here's the problem. Was your original problem written with a radical or a fractional exponent? Well, a fractional exponent. So, if that's the case, then your answer should be written with a rational exponent. So, the cube root of 25 to the 1 power is 25 to the 1/3 power. There we go. Number 38. Alright, now, be really, really smart here, guys. Think, okay? We're dividing like bases, okay? We have a 2 and a 2. We're dividing like bases. When you're dividing like bases, write the like base once up top and take 1/9 minus 5/6. Now, you should be able to use your calculator pretty well and get out a fraction, and you'll get this right here, negative 13/18. I don't want this negative exponent, so I've got to bring this whole thing up and bring it down to the bottom, alright? So now I'm left with nothing up top, so there's a 1. In the denominator I have 1 times 2 to the 13/18th. Okay, and obviously I don't need this 1 here. I do need the 1 up top. Okay, if you have a 1 in the bottom, you can drop that. If you have a 1 up top, you've got to keep that, okay? So there we go, 1 over 2 to the 13/18th, okay? 1 over 2 to the 13/18th power. Number 39. Alright, here we go. First of all, even though it looks really long, this is one term because they're not adding or subtracting, they're multiplying. So because I have one term, I am more than welcome to multiply my 6 through. So 6 times 1/2 is 3. 6 times 1/3 is 2. And we can take it from there pretty obviously. 2 times 2 is 4. 6 times 6 times 6 is going to give you 216. And 216 times 4 will give you 864. Alright, 864. Alright, number 40. Okay, now let's be really careful here. Alright. First of all, I cannot take the 6th root of 4. There's no way. So that's going to stay under the radical. But guys, come on, look. I have 6 x's. What's the 6th root of x to the 6th? In other words, there's different ways to look at this. One way to look at it is write out your x's. There's 6 of them. And what have I taught you when you're dealing with simplifying radicals? Whatever this number here is, you're looking for that many. You're looking for sets of that many numbers that are all the same, or variables, letters. So, I have 6 x's. I would cross them all off and put 1 on the outside. Another way to look at it is like this. I have 6 x to the 6. You can take your exponent and divide it by the index. That gives you x to the 1 and put that on the outside. Now, we talked about this during your homework. I remember specifically explaining this to you. Sometimes you have to put absolute values around a variable. That comes out from under a radical, and sometimes you don't, okay? And again, here's how you would know. Please watch carefully, okay? Here's my original problem. 6th root of 4x to the 6. If you put a negative number in for this, like negative 2, after you took the 6th root of it, it'd be positive, so you get out a positive number. If you put a positive 2 in for x, by the time you took raised 2 to the 6th power, it'd be a positive number. And so, no matter what you put in for x right here, no matter what you put in for x, positive or negative, it's going to come out positive. So when that's the case, you must put absolute values around the variable. You're saying, hey, I don't care what I put in for x, it's going to come out positive, because that's how it was in the original problem. So there's your answer. Square root of x times the sixth root of 4. Alright, moving on to number 41. Okay, we're subtracting radicals now. Do you guys remember what I taught you? If you're multiplying radicals, all that you have to have is a common index. However, if you're adding or subtracting radicals, you must have a common index and a common radicand. You must have both, okay? Well, my indexes are 3 and 3, so that's good. And my radicands are 6 and 6, so that's good. So what you do is you write down the cube root of 6, and then you add or subtract, depending on what you're doing, the outside numbers. So 3, negative 9 is negative 6, cube root of 6. Negative 6, cube root of 6. And obviously, if you can simplify this cube root, do so. But you can't. The prime factors of 6 are 2 and 3. So we're good. There's nothing we can do. Alright, number 42. Alright, same thing. We're adding two radicals. Do I have a common index? Yes. Do I have a common radicand? Yes. So you write your common index, you write your common radicand, and you combine your outside numbers. 9 cubed root of 17, or 9 third root of 17. Alright, number 43. Now we're getting into where we have common radicand, or common indexes, but look at our radicals, or look at our radicands. They're totally different. So it looks like at first glance that we cannot add or subtract these radicals because they don't have common radicands, but let's simplify this radical and just kind of see what happens, okay, real quick. It might help or it might not. Okay, 2 would go into this 896. 2 would go into this 448, I believe. 2 would go into this 224. 2 would go into this 112. 2, 56. 2, 28. 2, 14. 2, 7. How many 2's do I have? 1, 2, 3, 4, 5, 6, 7, 8. So I'm going to bring this down and put 4th root of 7, okay? Now for here, let's be really careful here. There's already a 2 on the outside. Bring down my positive sign. There's already a 2. I cross off 4 2's. Now why would I cross off 4 2's? Because my index is 4, so I'm looking for sets of numbers that are the same that come in sets of 4. So cross off 4 2's. That put 1 2 on the outside. Cross off 4 more 2's. That put another 2 on the outside. Multiply all those. 2 times 2 times 2 is 8. Leaving was with the 4th root of what? What's your last number here? 7. So we're looking pretty good now. We have common indexes and we have common radicands. Excuse me. So when your indexes are the same and your radicands are the same, just write the index and the radicands and then add or subtract the outside numbers. There's a 1 here, so 1 plus 8 is 9. 9, 4th root of 7. Alright, number 44. Okay, same thing. We're adding two radicals. Do we have common radicands? No, we have common indexes, but not common radicands. We cannot list out the prime factors of 3. It's just a 3, but we can list out the prime factors of 729, okay? So here we go. 2 won't go into this, but 3 will. So 3 goes into it, 243. 3 goes into this, 81. 3 goes into this, 27. 3 goes to 27 9 times. 3, 3. Now, we're looking for numbers that are the same that come in sets of 5. Let's see how many 2's and 3's I have. 1, 2, 3, 4, 5. Look at that. So I cross off 5 3's, put 1 on the outside. What am I left with on the inside? Just this 3 right here. Over here I have 4 times the 5th root of 3. Now, do my indexes match? Yes. Do my radicands match? Yes. So you write your index and your radicand, and then combine the outside numbers. Positive 4, positive 3, positive 7. 7 times the 5th root of 3. Alright, now, 45, 47, 49, and 51, we are solving equations. Solving radical equations. So, here we go. Step 1, isolate the radical. So let's bring the 3 over. And when we do, it becomes a negative 3. So we're left with 1. Next step, eliminate the radical. Well, if this is a square root, then I'm going to raise this side to the second power. If I raise one side to the second power, I'll raise the other side to the second power. When you square a square root, you're left with an x. When you square a 1, you're left with the 1. Please don't forget, students, whenever you're solving radical equations, you need to check your answers. Even though your work might be spotless, sometimes you might get an answer that doesn't work, because anytime you raise sides of equations to powers, you might get extraneous or extra solutions. So we're claiming the answer is 1, and by the way, the answer is 1, but let's check it. Put a 1 right here. The square root of 1 is 1, and 1 plus 3 is 4. Alright, 47. Now, right away, I'm personally going to change this to a radical. That's how I like to do it. So it's a square root of x minus 4. All of this to the 1 power, but since it's all under the radical, you don't have to do that if you don't want to. Now, step 1 is to get your radical all by itself. That means we have to get rid of this 3, and we have to get rid of this 5. Always save the multiplying number for last. So we'll bring the 5 over and make it negative 5. So now I have 3 times the square root of x minus 4 equals 6. Now to get rid of this 3, we're going to divide both sides by 3. These will cancel, leaving you with square root of x minus 4 equals 2. Okay, divided both sides by 3. Now, I want to get rid of this radical. I finally isolated the radical. I'm done with that. So now, I need to raise this side to the second power to get rid of my radical. But if I raise one side to the second power, I must raise the other side to the second power. When you square a square root, you're left with the radicand. When you square 2, you're left with 4. Now simply bring the 4 over and make it a positive 4. And x equals 8. Alright? X equals 8. Now don't forget, with these problems, you must check your answer. Put an 8 right here. 8 right here. 8 minus 4 is 4. So you have 3 times 4 to the 1/2 power plus 5. If you take 4 to the 1/2 power with your calculator, trust me, you'll get 2. Don't multiply these numbers first. Don't do that. Do your power first. 4 to the 1/2 power is 2, and 2 times 3 is 6. So we have 6 plus 5, which is 11, and that's what it's supposed to be, 11. Alright? Okay, moving on to 49. Always check your answers, guys. Okay, students, same type of problem again. I have to get rid of a negative 4 and get rid of a negative 10 to get my radical all by itself. Save the multiplying number for last, like usual. So here we go. Bring the negative 10 over, make it a positive 10, and we're left with negative 4. Square root of 2x minus 1 equals 16. Now to get rid of this negative 4, it's multiplying times the radical. The opposite of multiply is divide, so we'll divide by a negative 4. And 16 divided by negative 4 is negative 4. Now we have a square root, don't we? So if we have a square root, we'll have to square this side to get rid of the root. If you square one side, you must square the other side. When you square a square root, you get just the radicand. And when you square negative 4 times negative 4 is 16. So we're looking pretty good here. Just quickly solve the problem now, bring the equation, now bring the 1 over and make it 17. And now divide both sides by 2. And you can put 8.5. I'm going to leave it 17 over 2. But you can put 8.5 or 8.5. Now, let's see if our answer is correct. It's saying no solution. Let's see what happens. If you put 17 over 2 right here, use a calculator if you need to, guys, okay? 2 times 17 over 2. 2 times 17 over 2 is 17. And 17 minus 1 is 16. So I have negative 4 square root of 16 minus 10 equals 6. Now, what is the square root of 16? 4. So now I have negative 4 times 4 minus 10. Well, negative 4 times 4 is negative 16 negative 10, which gives you a negative 26. Negative 26 does not equal 6. So even though our work was impeccable and we did a good job, the answer doesn't work. So the answer is no solution. Alright, we'll make this our last one for this part 1 of the review sheet video, number 51. Okay, step 1 is get the radical by itself. So simply bring the 6 over and make it a negative 6. So now I have the cubed root of x minus 4 equals negative 2. Now that I've isolated the radical, the next thing I want to do is get rid of my radical. Well, it's a cubed root, so I must raise it to the third power. If I raise one side to the third power, I must raise the other side to the third power. So when I cube a cubed root, I'm left with the radicand x minus 4. Negative 2 times negative 2 times negative 2 is negative 8. Now let's solve the equation, bring the 4 over, make it a positive 4. So x equals negative 4. Now let's see if that's right, okay? Alright, here's an x, I'm going to put a negative 4. Alright, so negative 4 is negative 8, so the cube root of negative 8, positive 6 equals 4. Now, when three numbers when multiplied together that are the same number would give you negative 8, well, negative 2. Negative 2 times negative 2 is positive 4, and positive 4 times negative 2 is negative 8. So the cube root of negative 8 is negative 2. Positive 6 equals 4. Combine those, negative 2 and 6, and you'll get a 4. 4 equals 4, so it checks. So the answer is negative 4. Alright. Okay, guys, we'll put the brakes on there and work on part 2 a little later, alright? Hope this video's been helpful to you guys. If you have any questions, don't hesitate to call or email.